Now let's move on to talk about the physical properties of alkanes. And when we talk about the physical properties of alkanes, we are talking about properties like the boiling point, melting point, and viscosity. So we have a large variety of alkanes. They differ from each other with the number of carbons. There is a trend for alkanes. If you see in this graph here, this is a graph between that shows you the relation between the number of carbon atoms and the boiling point. So as you see, as the number of carbon atom in a chain increases, the boiling point increase. And it's the same case for the branched chain. But if you notice that the branched chain has lower boiling point in comparison to the straight chain that has the same number of carbon. So if you are comparing, for example, butane and isobutane, isobutane has a branched chain, it's a branched alkane, you will find that butane has higher boiling and higher boiling point in comparison with the isobutane. So why do you think that the trend is like this? Why the increase in the carbon atom will increase the boiling point, and why the branching will reduce the boiling point? This is because of the intermolecular forces. So the intermolecular forces in a molecule will determine the boiling point. We know that alkanes are nonpolar, so there is no ionic interaction. There is no dipole-dipole interaction, and there is no dipole-induced dipole interaction. But the only type of interaction you can find in alkane is called induced dipole interaction, or we call it London dispersion. So how does this kind of interaction take place? So what happened that you have two bonds next to each other in two different molecules. Each bond will have a center of a negative and positive charge identical to each other. There is no partially positive or partially negative charges at all. It's completely uncharged. But what happens when they come in close proximity to each other? One of them will induce the formation of a dipole in the other. So the one here on the right, as you see, will start to create a dipole. So there will be a partially positive charge here and a partial negative charge here, where the electron will be shifted a bit more to the right. So there will be a dipole, a created dipole. And this created dipole will then induce a dipole in the other bond to the left in the other molecule. So there will be another induced dipole with a partial negative here and a partial positive here. And then the opposite charges will attract each other. This will create a kind of intermolecular interaction between the molecules. The larger the molecule, the higher the number of carbon atoms in the molecule, the higher the intermolecular interaction between the different molecules. That means to break these molecules from each other, or to separate these molecules from each other, to change from the liquid state to the gaseous state, then you need higher energy to separate them. Okay, but why do you think that the branched alkanes will have lower boiling point here? This is because the one of the things that increases the intermolecular forces is also the surface area. So the higher the surface area of interaction, the higher will be the intermolecular forces. Branched chain alkanes have lower surface area in comparison with the straight chain alkanes. This is why branched chain alkanes have lower boiling point, because they have less intermolecular forces. Another physical property for alkane is the viscosity. So viscosity is the resistance of a liquid to flow. And again, the same intermolecular forces determine the viscosity. So viscosity is connected to the ease with which molecules can move past each other easily. So the higher the intermolecular forces, the more difficult for the molecules to pass freely, to move freely past each other. So we know that the stronger the the intermolecular forces becomes stronger as the chain become more elongated, as we increase the number of carbon atom, and also as the surface area of the molecule increase. So increase in the molecular weight and increase in the surface area will increase the viscosity. This is why there is an increase in the viscosity of the as we go higher in the chain. The viscosity will decrease with temperature. So temperature, the higher the temperature, the lower the viscosity, which is normal because it will break the intermolecular forces. But at the same temperature, you'll see that as the number of carbon atom increases, the molecular weight increases, and as the surface area increases, the viscosity will be higher.